So question 2, like question 1, starts off about the Poisson distribution. As you can tell, they really seem to like the Poisson distribution in further stats. So we've got our number of heaters, H, can be modelled by Poisson distribution with mean of 0.7. First one, nice and easy, put it in your calculator. If your calculator is not capable of doing greater than or equal to, you'll have to do 1 minus the probability H is less than or equal to 1. Okay, then they introduce some more heaters. So what we've got here, probably a good idea to come up with a new letter. So let X be the total number of heaters bought in the 2 supermarkets. Okay, then we can say X comes from a Poisson distribution. So remember, if we've got 2 independent Poisson distributions, we can add their means together. Right, so what do I then want? I want the probably fewer than 4 are bought from both supermarkets. So I want the probability that X is less than 4, which is the probability X is less than or equal to 3. Very important that you show what you're working out, because then we're just going to put that into the calculator. Good idea to show a few more values and then show that it rounds to that 3 decimal places. Okay, so then another favourite thing with the Poisson is to link it with the binomial. So now, rather than talking about the number of heaters bought, they're talking about the number of days on which total of fewer than 4 heaters are bought. So kind of change what we're talking about. So now if we say Y is the number of days fewer than 4 heaters are bought. So it's clear, it's good to get it clear in your head what you're talking about. So now Y comes from a binomial distribution. There's a total of 6 days, and the probability of having fewer than 4 heaters. It's good to use more sig fig. Another reason to write it down because you'll be more accurate. So N is 6, P is 0.49415 because that was our answer to a total of fewer than 4 heaters being bought on a single day. So we want the probability Y is greater than or equal to 5 because we want at least 5, so that's basically 5 or 6 days. You can then put that into your calculator again, which is 0.104. If you're using the summation option, you're going to have to do the sum from 5 to 6. We can do that directly in the graphicals. Right, so 0.104 is 3 sig fig. The front of your exam paper does say 3 significant figures, unless stated otherwise, is 5 for the final answer. Okay, so now we're going on. They're also putting a hypothesis test in here. So December was very cold. They took 2 days at random and found the total number of heaters bought in the 2 supermarkets. We're going to test whether the mean has increased. Or the total, sorry, not the mean, the total number has increased. So what's our hypothesis? Well, our null hypothesis is that lambda is still 3.7. And our alternative hypothesis is that it has increased, so the mean rate is now greater than 3.7 because that would lead to more being bought. Okay, so let's pick another letter, J. It can be number of heaters bought from 2 supermarkets. From the 2 markets in 2 days. Okay, so notice here it said 2 days in December. So under H0, J should follow a Poisson distribution with 2 times 3.7 because we're talking about 2 days, and we're going to say those 2 days are selected at random, they're independent of each other. So 2 times 3.7 is 7.4, and that's what we have for 2 days. So the probability of J being greater than or equal to 14. So 14 is well above our expected mean, which is 7.4. So we're going to be and also our hypothesis says greater than. Okay, so if lambda really is increased, you would expect 14 or more heaters. You expect more heaters to be sold. So we look for greater than here. Then we just put that in our calculator. Okay. If you need to, you'd have to do that as 1 minus the probability j is less than or equal to 13 if you're not using a graphical calculator. Right, what can we say about that? Well, our significance level is 5% and it's one-tailed. So we can compare directly with the significance level, so that's less than 0.05. Therefore, it is significant. Okay, so if the probability is smaller than significance level, it is significant, which means we would reject H0, which means there is evidence. And now we're going to put this back in context. The mean of total number of heaters, so that would be the important thing to get in there, bought from the two supermarkets has increased. And the important thing here, that took me a while to write, but what you do is you have a look in the question and literally quote the context back to the examiner. Yes, it took me a little bit longer, but that guarantees you're going to get the marks in the exam.